Hi friends, today I'm going to explain you one more an important topic, that is RLC series circuit with DC excitation. RLC series circuit with DC excitation. This is very important topic. Actually, there are two types, RLC series, RLC parallel. But here in this lecture, I'm going to explain the RLC series one. This is series. Okay, let's get into the question very quickly. Let me first draw that one. Resistor in series with inductor in series with capacitor. If we connect a switch here, okay, here we are giving a DC excitation, the DC voltage at t equals 0 switch. Just I'm mentioning the switch, but don't worry about this switch and all. RLC. Okay, here it's a DC voltage. The resistor and inductor and capacitor are being connected in series. So it is excited by DC voltage source. Okay. So first I will derive the equation of it, then you can remember the formulas and all that I'll be mentioning over here. Very quickly you can remember those formulas, because no need to go through all these derivations and all, but first time so I'm deriving because this is much useful for you in networks. Especially this is much useful in networks. Here also in signal system also somewhat is useful to solve things, and here especially. Moreover, you will be using this thing in control systems. Okay, let's get into this question. Okay, apply KVL. Okay, now differentiate with respect to time. Time means t. Then this term will be 0, right? Here. So 0 plus R into ti by dt. L into d square I by dt square plus 1 by c I dt is equal to 0. Okay, next, now what you have to do, you know, right? So you might have gone through mathematics. So from differential equation, you know how to write down this into equation form. So you just go through mathematics. It is the important one. Okay, this is basic mathematics only. I'm just converting into this. It's like d by dt is equal to d by dt whole square is equal to, d square by dt square is equal to d square, like that. Just apply. So first take this term, L into d square into I plus, next this one, R into d is I plus 1 by c I dt. Just nothing else, just d square, just I you can take it common, d square plus R by L, L also taking it common, R1 into D plus 1 by LC into I equal to 0. You got this expression, right? So it is like this is one term, this is one term. See, here I am going to explain you one more important thing, that is, you know how to write down. Here you can apply the formula for finding out d1 and d2 minus b plus or minus root of b square minus 4ac by 2a, right? This is a, like this is a, this is b, this term is c. Minus b minus r by l plus or minus r by l whole square minus 4, a is 1, c is 1 by lc by 2a. Got it? Can you write down? See, if you take 2 upside, minus r by 2l plus or minus r by 2l whole square minus 4 by lc. This is the final expression. Understood? This is the proof. Okay, this is what you got, right? Okay, next, one more important thing, it is, here we are comparing this with what? We are comparing this networks with control system, because this is a repetitive thing. This concept is a repetitive thing even in control system. It is very much needed. You need to understand this concept. It is useful there in control system as well as here is the basic thing that you are learning here in networks. Okay, we don't have much time, so let me complete this very quickly. Here we are applying two concepts here. One is differential equations plus control system concept. With this together I'll solve this. Okay, finally we can write down the same equation again. d1 comma d2 minus r by 2l plus or minus this is the actual equation, right? From here, first let us consider a case 1. Case 1, it is real and distinct. How? Let me explain you this. But suppose this is alpha, this is beta. Okay, this alpha plus or minus beta, this is okay. But suppose if you consider this r by 2l whole square is greater than 1 by lc. if this term is greater than this term, then what it can be happened? This can be positive, right? This term will be positive, and having this term also having something. So it is not imaginary. It will be real value, some value will come. Even in root or anything, some value will come, and it is real value, not negative value. So, not negative or imaginary value. So not negative with imaginary value also. So what here I'm explaining is, this is the one, it's a over damping. How? Because if you study control system, then you will get to know. So real and distinct means, like the poles are real and distinct means it is a over damping system. So you can write down alpha is equal to minus r by 2l, beta is equal to r by 2l whole square minus 4 by LC. Okay, so if it is real and distinct, if it is alpha and beta are having values, then how can you write down that equation, final equation? IFT, the current formula is C1 e power alpha minus beta into T plus C2 e power alpha plus beta into T. So you need to remember this. This is same, you can use it in parallel RLC also. Okay, you got it right. Next, second case. Case 2. But suppose r by 2l, whatever it is there, e square is equal to 1 by LC. What it can happen? If they are equal means, then this term will be 0, right? I made a mistake here, it should be 1 now. Yeah. Sorry. Here it is 1. This 2 will go upside. Then 4 will be cancelled. Yeah, that's right. Okay. So 1 by LC. If these terms are equal, then beta will be 0, right? Beta equal to 0. Then only alpha will be exist. So only 2 alphas will come. This also. Why? What you are expecting from this? What you are going to get it from here? So it means that if these two are equal, if beta equal to 0 means, if alphas only exist means, this is critical damper system. Critical damping system. Got it? You're understanding me, right? What I'm saying? Why it is critical damping system? You need to have this important note. If they are real and equal, not distinct, real and equal, this one minus same, right? They have come same, right? So if they are real and equal, then it is critically damping system. Okay, you got this. So how can you write the formula? If it is real and distinct, if it is real and equal, then we can use the formula C1 plus C2 into T e power minus alpha T, because beta is equal to 0. Since beta equal to 0, it is consists only alpha term. Okay, this you understood. Next, case 3. I'll go very quickly because we don't have enough time. So for suppose r by 2l is greater than 1 by LC. If this term is dominating this term, then what will happen? So here negative value will come. Ultimately that imaginary terms also will come. So what it will become? Roots will become, the roots are imaginary here. So if roots are imaginary, then what we say them? It is a underdamped system. Okay, it means that alpha is equal to minus r by 2l, beta is equal to, because 1 by LC is dominating, minus r by 2l whole square. So how can you write down the overall formula when roots are imaginary? Then you can write down c1 cos beta t plus c2 sin beta t e power alpha t. Okay, in the next video I'll explain you the differential equation concept, because how to find out these roots are very much needed. You need to understand, otherwise you can't understand these things. So in the next video I'll upload about differential equation concept. Okay, yeah, okay, you got to know these cases, right? And here, but suppose if you want to find out the damping coefficient, how to find out the damping coefficient? Here important note you can mention. Damping coefficient is equal to alpha equal to pole. We consider is equal to r by 2l. This is the pole, right? R by 2l. This is how you need to find out. And for suppose if you want time constant, tau is equal to always inversely proportional to pole, 1 by a pole. Then how can you write down? To L by R. This is how you need to write down. Okay, you understood now. So time constant is a inverse 1 by damping coefficient. Okay, this is what I understood. So the last case 4, for suppose r is equal to 0. R is equal to 0 means alpha will be 0. What does it mean? Beta will be the overall 1 by root LC, right? So it means that finally what you can get, if alpha is equal to 0, what does it mean? This is undamping system. If you compare with the control system, what do you get to know? Alpha equal to zeta omega n. So zeta is 0, because alpha is 0 means zeta is 0. So 0 means zeta is equal to 0 means what does it mean? That undamping system. You want to know how to get to know these things? Okay, after writing this equation I'll explain you that. I of t is equal to c1 cos beta t plus c2 sin beta t. This is how you need to write down, because the alpha equal to 0. So these 4 are very much, very important to understand these concepts and all, and these are already there in control system also. So if you cover these things here, it means that you are covered in already control system. If you covered already in control system, it means that you are already covered here. So just a little bit of differential equations you must understand before knowing these concepts. Okay, so now theta concept. So control system, I'm including control system concept. Zeta behavior I'll tell you, because I'm just mixing up these concepts, just involving all the conceptual things here, so you need to know. So for suppose if time is there like this, now here I don't want to explain, the next slide I'll show you. Yeah, here I'll show you. But suppose time is there. Okay, I'll plot 4. This is time current. Okay, so first suppose the zeta value, or here you can consider zeta also indirectly. Okay, with black only I'll plot. But suppose if r equal to 0, the plot is this. R equal to 0 means alpha equal to 0. It means that zeta equal to 0, right? Alpha equal to zeta omega n. So how it can be? It is pure sinusoidal because it's undamped. It is like this, right? Okay, that is fine, you understood. What if zeta is less than 1? Then it will be under damping system. Like dampings will start like this, then when it goes to the steady state, it will be like this. So this is, here it is undamping, here under damping. So for suppose if zeta is greater than 1, what it can be? Then initially that it goes into transient state, then it will be steady state, leads to this one. It will take some time, more time. Then this is called over damping. Okay, if zeta is equal to 1, exactly 1, then it is critically damping. It will go and it will very quickly, it will go here like this. It is critically damping. Practically this is not possible. You have to go for under damping systems. And over damping systems it's not possible. Okay, so this is the concept, the zeta relation, because alpha means r by 2l. So alpha is equal to zeta omega n in control systems. So this is zeta behavior I am showing. It means that r behavior only. R is equal to zeta here. It means that only. Okay, here one more concept I want to explain. It's okay. It is more than enough actually. Because you need to, they will ask you one question here. Okay, let me explain you one more thing here. This is the equation, right? From this equation only, how you find out that omega and zeta damping ratio. The same way I'm going to explain here. Omega, not here. From the equation I can explain you. But suppose, like here if you compare with, not here, the final equation is here now. Here if omega n square is, if you compare with s square plus 2 zeta omega n plus omega n square, then how it can be omega n square equal to 1 by LC, right? Okay, then omega n equal to 1 by root LC. Okay, 2 zeta omega n if you compare with, this is 2 zeta omega n factor. Yes, just compare with the second order Laplace transform, s square plus 2 zeta omega n s plus omega n square. Just this one you can compare with. Then 2 zeta omega n is equal to r by l. 2 zeta omega n means 1 by root LC equal to r by l. then total cancel, then finally zeta is equal to r by 2 root c by l. This is the final one. This is in series RLC. Okay, this you need to remember, because they will ask you one condition here. That's why I explained you there. For suppose if they ask you, how they can ask you condition for no oscillation. Here it is having no oscillation, here is having no oscillation, here oscillation is there, oscillation is there. So they will ask you the condition for no oscillation. What does it mean? The zeta value is equal to 1 or else zeta should be greater than 1. So what you have to write down, zeta value should be greater than or equal to 1. Zeta already found it, right? We found it out. Where? Just above it. Zeta equal to r by 2 root c by l. Should be greater than or equal to 1. They can give capacitance value, they can give this inductance value, then they will ask you to find out r value. So it can be anyway. So this is how you need to find out. And parallel RLC is also similar. There you applied KVL, same way you can apply that. And there you got a current equation. There here you can get a voltage equation because they are in parallel. So simply you can do that. Otherwise I'll explain you that thing in next question. But all the PDFs will be transferring slowly one by one. So all I'm submitting there only. So you have to follow this group in Telegram at Government Engineer. Just search and join this Telegram group. Here I'm uploading all the documents. If you have any doubts, you can ask me. So this is how you need to find out. So this RLC series circuit and RLC parallel circuit, these circuits are very important. Why? Because you need to understand the things behavior of the circuit, how the RLC series circuit behaves and RLC parallel circuit behaves. Because if we are giving DC excitation here, they can ask you one more thing. What is that? So in the above figure, like for suppose in this figure, there's steady state current response they can ask. But at steady state means infinite. At infinite condition, the inductor will be short circuited, capacitor will be open circuited. So how current will not flow, right? When it is open circuit, the current will not flow through the circuit. So what does it mean? The current will be 0 at steady state. Yeah, that's it. So this is how you need to find out the equations and all, and this is how you need to find out the roots and all, and this is how you need to have the figures and all. So they can connect with the control system, they can connect with the networks, they can ask you anyhow. So just follow this class. So this is very much important, because generally this class people take for 1 hour explanation like that, but I have explained you in half an hour. So if you want me to solve questions also, you can message here, you can comment here. I'll try to solve some more questions. Thank you.